Chapter 3.2 Notes, Domain and Range, page 5. So more graphing piecewise functions. And for C, we're going to do it backwards of what we did on B on the previous page. We're going to go ahead and find those values for what's requested below before we actually graph this function. Okay, I am going to mark this up though. I'm going to use pink for anything that falls into the top part of the function, the 2x plus 1, that is defined for x greater than or equal to 1. And then the x over 2 minus 3 for any x less than 1. And so h of negative 2, we want to figure out what part of the domain that lies in. That is definitely the negative 2 is less than 1. And so I'm going to write that, because negative 2 is less than 1. And so we're using the bottom equation, the bottom expression, negative 2 over 2 minus 3 gives us negative 1 minus 3, which is negative 4. Second one, h of 1. That definitely lies in the pink part of the domain because 1 is greater than or equal to 1. So we use 2 times 1 plus 1. We get 2 plus 1, which is 3. Our last value is 6. H of 6 is just going into that pink part of the domain again because 6 is greater than or equal to 1. We got 2 times 6 plus 1, which is 13. So let's go ahead and graph what we can. So here's what I'm going to do. I'm going to graph this a little different than the last one. I'm not going to create a table and pick up points, even though that probably might be the most straightforward way. I'm going to go ahead and graph the lines using the slope and the intercept, and then I'm going to go ahead and erase the parts that don't work. So the top part, that pink, I've got 2x plus 1. So I've got an intercept of 1. We're just going to count by ones on all of these. And a slope of 2. So up 2 over 1, up 2 over 1, down 2, back 1. Doesn't matter which direction you go. Ooh, that one missed. Close enough. Okay. Now, this is only, I can't think of the grown-up word. Defined, sorry, for x greater than or equal to 1. So at 1, we've got this point right here. So let me be very careful so I don't erase the whole thing. Means this part of the line here does not exist. No. So this part of the equation is only valid for x greater than or equal to 1, and that is the pink part of our equation. So that starts at 1. So let's take a look at the other one. I have x over 2 minus 3, which means my y-intercept is at negative 3. I have a slope of positive 1 over 2, so I'm going to go up 1 over 2, up 1 over 2. Notice we're in this territory where that line would overlap. Again, we are graphing the entire line and not just the part we want. Not super straight, but whatever. And so again, this is valid from is valid for x less than 1. And so here's my 1 right here. That means I'm going to need an open circle. So I'm going to go ahead and erase this part of the line. I'm going to stick my open circle at 1 and draw my line in here. And that is the blue part of the graph. Notice that if I were to draw a vertical line at x equals 1, there's only one value, that's 3. It doesn't actually hit 1, negative 2.5. Okay, so D. We have 3 parts here, which is something a little different for us. So let us go with negative x plus 4 with x less than or equal to 0. And so I'm going to take a look at the values that I need to plug in. F of negative 2 is definitely less than or equal to 0. So I use the orange part of the function to evaluate here. I get negative 2 plus 4, 2 plus 4, which is 6. This next one, f of 0, also less than or equal to 0. So I get negative 0 plus 4, 0 plus 4, which is 4. And then f of 5, and let me take a look up here. 5 is greater than or equal to, or sorry, strictly greater than 3. So at 5, it's 2. And so let's figure out how we want to graph this. So x greater than 3 is 2. That looks like the easiest place to start. So I'm going to count 1, 2, 3's right here. 1, 2, 3's right here. So for x greater than 3, the value is 2. So at 3, I've got an open circle at 2. Anything greater than 3 is going to satisfy that. That is part of the, green function right there. The orange, negative x plus 4, x less than or equal to 0. And I've cranked out 2 values here. I'm just going to use those. So f of 0 is 4. F of negative 2 is 6. So here's my negative 2, 3, 4, 5. There's my 6. X less than or equal to 0. So that's everything over here. And so now to this middle chunk, x squared minus 5 from 0 to 3. So I know this is a parabola. I know my intercept is at 0, negative 5. And I also know I can't use that point. So here's my negative 1, 2, 3, 4, negative 5. I'm going to have an open circle right here. This is a parabola. It's probably going to be a little easier for me to just plug and chug. So at 1, I get 1 squared minus 5. 1 minus 5 is negative 4. At 2, I get 2 squared minus 5. 4 minus 5 is negative 1. And at 3, I get 3 squared, which is 9. 9 minus 5 is 4. 4 right there. It includes the 3, but not the 0. So I've got a curve. Nope, that's not a curve. What the heck? Which is going to slide right by my super big open circle at 3. There we go. And this is the blue part of the function. Again, not a straight line. There we go. E. I've got the negative absolute value of x minus 2 plus 1 for x less than or equal to 0. And I've got negative 4x over 3 minus 4 if x is greater than or equal to 3. I really don't want to work too terribly hard, so I'm going to plug in numbers to figure out what these graphs are going to look like. Okay, so this time I'm going to start with that first. Doesn't really matter. So I got x, m of x, and this is going to be this lovely little bit, negative absolute value of x minus 2 plus 1. These are valid for less than 0. Just because I don't want to think too hard, I'm going to plug in 4 numbers. So I get negative absolute value of 0 minus 2 plus 1, which gives me negative, absolute value of negative 2 is 2. So I get negative 1. And I am going to slide this little lovely over just a bit, and hopefully I won't run out of room. Okay, negative 1. I got negative 1 minus 2 plus 1. This here is going to be negative 3. The absolute value of negative 3 is positive 3, which I'm going to make it a negative because of this. I get negative 3 plus 1, which is negative 2. We plug in negative 2. Negative 2 minus negative 2 is going to give me a negative 4. Absolute value of that is positive 4. I end up with negative 4 plus 1, which is negative 3. And at negative 3, I've got negative 3 minus 2, which is negative 5. The absolute value of negative 5 is positive 5. I want the opposite of that. Negative 5 plus 1 is negative 4. So, color coding, yellow. Boom. I have got 0, negative 1, and I'm allowed to use 0. So that is a closed circle. At negative 1, I've got negative 2. Let's go and label. At negative 2, I had negative 3. And at negative 3, I had negative 4. So this is the x less than or equal to 0 part of our graph, including that closed circle. And so now for the bottom part of our graph, I've got negative 4x over 3 minus 4 if x is greater than or equal to 3. So I'm going to do that over here. Negative 4x over 3 minus 4. I'm going to start at 3 and go, oh, it's divided by 3. Let's go 3, 6. 1, 2, 3, 4, 5, 6. Yeah. 3 and 6, and we're going to hope I don't make a mistake. We'll go from there. So I got negative 4 times 3 over 3 minus 4. The 3's cancel. Negative 4 minus 4 is negative 8. And I obviously did not plan this very well. 1, 2, 3, 4, 5, 6. Negative 7 is right here. So negative 8 is over here. So 1, 2, 3, negative 8. It's a closed circle because I'm allowed to use 3. At 6, I got negative 4 times 6 over 3 minus 4. I'm going to cancel those. Negative 8 minus 4, negative 12. Holy moly, I did mess that up. 1, 2. Here's our 6. Negative 12, 8, 8, 9, 10, 11. Roughly down here. So now notice we kind of have a gap. We don't have anything graphed between 0 and 3. So let's see what that does for us in terms of our function values over here. M of negative 2 is definitely less than or equal to 0. So we use that top expression. And we already did this one. We got negative 3. We got M of 0. Also falls into that less than or equal to 0 category. Also one we've already done. M of 2, notice this function is not defined by 2, at 2, sorry. So we have no value here. And then we've got M of 5. 5 is definitely greater than or equal to 3. And so we are using negative 4 times 5 over 3 minus 4. Negative 20 over 3 minus, let's convert this, 12 over 3. I get negative 32 over 3. And you know what? I'm going to leave it like that. We don't have to graph this at this point. And so that's it. It's good to go.